Let me show you some of the new features in version 6 of Apromore. The first one is the automated discovery of process maps and BPMN models, which we can access through this menu item here, Discover Process Map. Or we can simply double-click on a log. So before doing that, let's take as an example this log, which is related to cases of sepsis. So it's a healthcare log. And what we can do is, first of all, to measure this log, meaning to get some scalar characteristics for the log. For example, we can see that the log refers to a period of about 1.5 years from the end of 2013 to mid-2015. You can see the aggregate duration of each case. Each case representing a patient flowing to the hospital in order to be assessed and then attended for their skin infection. And what we can see is that there are 1,050 cases. However, there are about 850 different ways of handling these patients, so 850 different patient flows. So this ratio, the number of traces divided by a number of unique traces, is quite low. And that's typical of a healthcare process where almost every patient is handled in isolation. If I now take a log that refers to a financial business process, where processes are actually quite structured, I'll see that this ratio is quite different. It would be much larger, meaning that the process is more standardized and hence much more predictable. Like in this case, you see that the number of unique traces is nearly 16,000, and the total number of traces is twice as large. But let's go back to our sepsis log. And we can either double-click on this log or simply go to Discover Process Map BPMN Model. So what we see here is, again, on the top right corner, a few statistics about the log, like number of cases, number of events, number of unique activities, and then statistics related to the duration of cases. So here in the canvas, we can see the actual process map. This map shows a typical process that patients follow, where they first have emergency room registration, and are then triaged, and then they realize that it's a case of sepsis, and then some examinations are done. So some analyses are done, and some medicines are administered at some point. At some point, there is a branch out. Some patients get to admission in normal care, NC. Some others undergo intensive care, IC, and so on. So in this map, the darker the color of each box, the more frequently we've observed the activity in the log. And this is the case for leukocytes and the C-reactive protein, CRP. So these are two examinations that are typically done to check if a patient has an infection. And you can see that there are over 3,000 cases that perform this activity. So what we're looking at in terms of frequency is the absolute frequency. So how many times I see a particular activity being performed. Now the arcs, on the other hand, represent the transition between one activity and the next one. So whenever I have an arc in between two activities, that means I've observed that from one activity, I move to the next activity in the log. And again, the thicker the arc, the more frequently that transition has been observed. So we look at the case frequency that shows the number of cases that have gone through a particular activity or a particular transition between activities. If we look a bit closer, we see there are 995 cases coming in, while the first activity is performed 1,050 times, and then 971 cases come out of the activity. So the numbers do not quite add up. This is because if we look at the top left corner here, we're actually showing 100% of activities, but we're applying a filter on the arcs. We're only showing the 10% most frequent arcs. If I now increase this number of arcs so I show more and more infrequent arcs, I'll see that the numbers start adding up, and that's because more and more of the arcs pop up. As that happens, we observe more and more network repetitions or activities that are repeated altogether in so-called self-loops. So the process can actually get quite complex. And if I use this slider all the way through to 100%, I see that the process is actually quite complex. And that's because, as we saw earlier, almost every patient follows a unique pathway. So let's go back to something more manageable. Let's say 20% of the arcs. So in a process map, I'm not able to understand the relationships between activities, so I see, for example, that there's probably a branch out here where some patients go through admission in normal care, some others go through intensive care. However, if I really want to find out what the behavioral relationships are between activities, then I have to use a different type of model, namely a BPMN model. And I can do that at any time. I can switch between a process map and a BPMN model by ticking the BPMN in that box. So in this BPMN model, we can now see what the relationships between these activities are. So indeed, there's an exclusive OR split where some cases go to admission in intensive care. They're a minority, about 10%, and the majority of cases go to normal care. This indeed is expected. Now, if I increase the number I want of arcs even more, say 30%, some more interesting behavioral relationships may pop up. For example, here I see I have an AND split, so it's the same patient that at the same time gets leukocytes and CRP being measured. It might be by two different nurses or by one doctor and a nurse. Of course, to keep them sound, that is, free of behavioral abnormalities, I may need to apply some OR joins to be able to connect all these branches that are potentially performed in parallel. So this is a BPMN model. Another thing I can show beside the frequency information is the performance information, or duration. And I have a range of statistics that I can show. For example, I can see the mean duration. Each activity has a time noted in the activity box, and each arc has a duration noted on the arc itself. So the darker the activity, the longer it takes. Similarly, the darker and thicker the arc, then the longer that particular transition between two consecutive activities takes. Now, it's interesting to observe that this log, like many logs commonly found in practice, only had the end timestamp for each activity. Consequently, each activity is marked as instant, and the duration I see on the arc, like this one, 13.46 minutes on average between IV liquid and IV antibiotics, is the average duration from the completion of activity IV liquid to the completion of the next activity, IV antibiotics. Now let's start playing with the arcs and see if something interesting pops up. Let's put them again to 20% and see that an arc with a duration that is substantially higher than the rest pops up between release A and return ER. So this is likely a case of ineffective discharge, meaning a patient that is readmitted after being discharged. Now this transition is in red because we're talking about months in terms of the time unit, as opposed to hours or minutes, sometimes days for the other arcs. So the order of magnitude is longer, and the more I show the details of this model, the more interesting bits may pop up. And at any time I can go back to BPMN if needed. And you can always show dual information, both the frequency and the duration for each arc and activity. In this case, the top would be the frequency, and the bottom number would be the duration. Now, another interesting property is to be able to unlock the slider. What's that mean? If I now move between the frequency and the performance, you see that the model remains the same, and that's because those sliders have been set on the frequencies, so no matter what performance statistic I show, the model remains exactly the same. Now, if I unlock them and I move to performance, these sliders are determined on the basis of duration of the arcs. So I'm showing essentially all the activities, but only the fastest arcs. So if I move this slider more and more, I can show fewer fast arcs, all to the point of showing everything, where I see very, very slow arcs. Once I define the level of abstraction that I want for that particular view, then I can lock it and go back to frequency. And from that point on, the view remains locked. So now I'm looking at the frequency-related performance information on the basis of a diagram that I first abstracted using performance sliders. Another interesting feature of this plugin is its ability to invert the priority for nodes and arcs. So here I'm focusing on 100% most frequent activities and 30% of the most frequent arcs. But if I invert these, I would be focusing on less frequent activities and less frequent arcs. And then I can show more and more frequent activities. Another interesting thing that I can do is to apply filters. For example, I want to investigate cases where patients return to the ER. So if I control and right-click on this task, ER, I would apply a filter that retains all traces that have that particular activity. So if I go to filter, I can expect that. And indeed, I've just applied a filter to retain all traces containing an event where the activity is equal to return to ER. Now I may want to focus on the admission to normal care. So what I do is that I remove all the parts that go to intensive care simply by right-clicking on that. So I've now applied that as a second priority filter to remove all traces containing an event where the activity is equal to admission intensive care. Anytime I apply a filter, the number of cases gets reduced. And so the statistics get updated. So I can go here and create manually a filter, for example, to retain only cases related to patients whose age is greater than or equal to 80 years. And now I'm looking only at 122 cases, and I can go on and create more and more filters. For example, I want the cases with a specific duration. You see here that the minimum duration is 4.95 days, but the maximum is over 1 year. Now let me focus on those that are longer than 2 months, and they want to retain traces only in ones that are longer than 2 months. So now I'm looking at only 54 cases. These are the cases of patients that have an age of 80 or more that were admitted to normal care and returned to the emergency room. These might be certain deviating cases that I might want to inspect even further. To do that, I can export the filtered log. The log is now here, and similarly I can export the BPMN model. And there it is. And the last thing we're going to show off is that we can animate the log and see how the patients have flowed through this particular model. So I see my model here. And I can now play. And each token here would represent a particular patient flying through the hospital. So it can be very useful to understand cues, delays, deviating activities. For example, I see that there is some bottleneck here. There might be a bottleneck there. And I see that some tokens actually go around a particular activity like liquid or antibiotics being skipped. That's normal because I'm only showing you a model that has a particular abstraction level. So this model is not showing all the possible cases. So if that's the case, then tokens would go around that particular task.